Hi folks, well, we have been marching down the electromagnetic spectrum. We started over here with our long radio waves, through microwaves, infrared, visible, ultraviolet, X-rays, and now we're at the highest energy, shortest wavelengths in the electromagnetic spectrum, and these are gamma rays or gamma radiation. These are very, very high energy forms of radiation. This is very often referred to as nuclear radiation. And where exactly do gamma rays come from? Well, they're called nuclear radiation because they come out of the nuclei of certain naturally occurring radioactive elements. And I want you to walk away understanding that radiation is natural. It is not the result of mankind messing around from the inside of atoms. Radiation has been here from the beginning of time, and it will be here till the end of time. We discovered it 150 years ago or so, and we have, like a lot of things in science, there are good and there are some not so good things about it. But some elements, uranium, thorium, a lot of the higher, bigger ends of the periodic table are naturally radioactive. And what that means is their nuclei is unstable. There's too many pieces packed inside. And randomly, at some weird moment when you're not expecting it, the nucleus is going to try and become more stable by spitting out a piece of itself. When it does that, sometimes with that piece, and those pieces are often called alpha or beta particles, with those very often you get a burp of energy, and those little extra burps of energy that come out as accompanying nuclear radiation is gamma rays. So these are high energy particles coming out of the nucleus of atoms. Now, gamma radiation is a kind of ionizing radiation. As in all ionizing radiations, it will cause an atom to lose an electron, which can lead to, if a lot of it can be healed, like a paper cut can get healed, but if the ion that's produced happens to cause some sort of wacky, strange bonding in DNA, it can cause mutations and cancer. High exposures of gamma radiation in a short period of time can lead to illness and death. So this can be bad, bad stuff. Where do you and I get gamma radiation? Well, most of it is background radiation that comes from benign sources like rocks. It depends on what part of the country you live in and even what part of the state you live in. Different rock formations have a higher quantity of naturally occurring radiation depending upon the elements that are inside. Some rock formations, some parts of the country, very low background radiation. There is one radioactive gas. It is known as radon, and radon can be found produced by the ground, again, in certain parts of the country. You can find maps online. You can look up exactly your state and your area of your state of what's the potential for radon. And it is a gas that can seep in through holes in your basement, and nobody wants radioactive stuff floating around their house. So there are radon detectors that you can actually buy at your hardware store. Other sources of gamma radiation are from what man has done in the nuclear power world. Back in the 40s and 50s, there was above ground nuclear test, which did lead to some radioactive fallout. These tests, fortunately, above ground have been banned. And so you and I, fortunately, are not going to be exposed to a lot more of that. Nuclear power is a very, very, very safe form of power. There are thousands of nuclear power plants all over the entire world, and you almost never hear about a problem because they are so safe. I always equate nuclear radiation to flying in a jet because of the fact that jumbo jets are flying through the sky constantly. There are thousands every day that are flying around, and nobody gets hurt, and it's very, very safe. But the problem with nuclear accidents and jumbo jets is that when there is a big accident, yes, people do get hurt, and typically quite a few at once. And that's the problem. It's very, very, very safe, but once in a while there is an accident, and that's just the give and the take for technology. Now, gamma radiation has an interesting byproduct. It is very good at killing fast-growing or fast-developing cells. So what is fast-growing and fast-developing cells? Well, my friends, that is tumors and cancer. Back when Marie Curie first she and her husband Pierre and Henri Becquerel, when they actually first discovered radiation, she was so excited, and they were all very, very excited about the fact that this could be used to kill and cure cancer. Back in the day, though, they would use radiation kind of wholesale on the patient, and it can cause some damage as well. Modern medicine is so good that the radiation can be pinpointed like a laser exactly on the tumor without an awful lot of side effects. Because of the fact that these radiation treatments can kill fast-growing cells, anything else that is around it or is also fast-growing, like hair, will also and can also be killed. So some of the people you love who might be going through cancer treatment, it's not all hair loss is due to radiation treatment. Sometimes it's due to chemotherapy, and chemo means chemical therapy. Again, the idea is growing the fast-growing cells while keeping the patient healthy. Now, gamma radiation, besides being dangerous, it is a fabulous sterilizing device. It can be used to sterilize things where we want to kill germs. About 50% of all the medical supplies in this country are actually sterilized using gamma radiation. If you go to a plant where they manufacture surgical drapes and surgical gloves and surgical masks and surgical bandages, it's just a factory, okay? It's not a filthy factory. It's a pretty clean factory, but people are not running around in a sterile environment. After everything has been packaged, then they can put it in a chamber and expose it to a lot of gamma radiation. And the gamma radiation will go in and kill bacteria, viruses, fungi, and things that are going to potentially cause infections in patients out the other end. And that sterilization occurs in the packaging. And so when that package is opened in the surgical suite, that is the first time that it is exposed to germs. And so it is a really, really slick system. A lot of those kind of medical supplies on the case are going to have a little button or sticker that is going to indicate if they have or have not been irradiated, to indicate if they have not or have not been sterilized. Gamma radiation is also used to sterilize food for longer shelf life. Now, please don't freak. Americans have a tendency to freak if you hear the word radiation. It's just, unfortunately, what the media has done to us through the years. But I always remember wondering as a kid how in the world I could get strawberries at Christmas time when I knew strawberries grew in the summer. And where the heck did they come from? And my family would say, oh, greenhouses someplace. And I went, okay. Well, in the modern age, a lot of them are shipped from far away in South American countries. How the heck do you get them from way foreign countries on a boat across an ocean into a grocery and then into your table? That's going to take time. How are you going to keep those strawberries fresh for that long period of time? What food producers have learned that they can do is they can sterilize a lot of food by exposing them to gamma radiation. In the same way that cancer is killed because it's a fast-growing cell, bacteria, viruses, fungi, parasites can all be killed by gamma radiation. And the Food and Drug Administration has okayed the use of gamma radiation to sterilize everything from wheat to spices to eggs to sea fish to shellfish. You and I need safe food. And how the heck are we able to get it all over our beautiful planet? Well, one of the ways is gamma radiation. And so I want you to understand that being exposed to radiation does not make something radioactive. Being irradiated is not the same as being radioactive. Your pretty little strawberries are not radioactive. Here's the analogy. If you go outside and you are exposed to sunlight, that does not mean sunlight will come out of you unless you are a super villain of some sort. That's not the way it works. Your strawberry is exposed to gamma radiation and it kills the bugs and the nasties. They're very, very low level of radiation, but that does not mean that you are eating a radioactive strawberry, because your strawberry cannot give off radioactivity. Last cool thing about gamma radiation that's kind of fun because I love astronomy, and that is gamma ray bursts. it's been found by astronomers that when a black hole is born, it is the most powerful, violent explosions that are currently being produced in the universe. And when that happens, the collisions, the explosions are so violent. The charged particles involved are accelerated at such a high rate of speed that gamma radiation is produced. These things are called gamma ray bursts. They last only about 20 seconds, and they are the signature, the birth cries of black holes. Today, and we only look in certain areas of the sky. We're not looking at the whole sky because we only have so many telescopes. Astronomers are seeing about 1 gamma ray burst per day. And what that means is about 1 black hole, we are pretty sure, is being born daily. So that's pretty cool. Science is so nifty. We'll see you later. Bye-bye.